When you've been coding for some time, you'll eventually run into problems in your code or bugs in your program. And even the most experienced programmers run into bugs. And bugs are annoying because you don't understand why they're happening. And so it can be frustrating. And this is probably the most frustrating part about coding. But when you debug your code, you actually get a sense of accomplishment and you start to feel better and more confident about your code and the robustness of your program as you debug your code. So debugging is actually sometimes a therapeutic process. Bugs are chaotic, unexpected, unintentional, and kind of random, but there is a way that you can approach them that is intentional, methodological, and systematic. So in this video, I'm going to talk about 3 common bug categories that I've encountered over the years of my professional software development career. And then I'm going to talk about some ways of approaching them, some strategies on how to approach those different categories. And then I'm going to go over the 2 main ways that we go about debugging our code. And then I'm going to show these in an example at the end of the video. So my name's Henrik and I'm here to help you learn the foundations of software development. So let's get started. But before we begin, I'd like to mention that I do have a free workshop for you. It's called my Capstone Project Workshop. And in that workshop, I go over 3 secrets to coding your own Capstone project in just 3 months. And if you don't know what a Capstone project is, it's just a personal coding project where you apply all your newly acquired coding skills into one personal project. Now, why did I create this workshop? The most common goal that I get from people who apply to my one-on-one programming mentorship program is to, quote, be more proficient at creating projects. You and I both know that learning how to code is more than just memorizing code syntax. It's about applying your coding skills to real-world projects that make you feel confident and capable. A lot of new programmers tell me they struggle with turning what they've learned into something practical, and many feel overwhelmed trying to go beyond tutorials to build their own thing. So if this sounds like you can download this workshop in the link in the description, and if you download it and watch it and pay attention to what it says, then you'll definitely build a good foundation to your software development journey. Alright, so 3 common bugs that I've found over the years, and it's kind of helpful to categorize these bugs in these different categories, because when you can categorize them, then you can easily come up with an approach on how to debug those bugs. So the first bug that I've encountered over the years is the regression bug. And the regression bug is a common bug where it's a bug that in your code where something used to work, but now it doesn't work. And this kind of bug usually happens when you're implementing some new features in your program and then you've neglected a feature. Say you have feature 1 that has been working, and then now you've moved on to feature 2. And then as you're developing feature 2, your focus is no longer on feature 1. You're now focusing on feature 2. And then after you're done with feature 2, you eventually start to test all of the features in your program, and then feature 1 doesn't work anymore. So that's what I would call a regression bug. Another thing about regression bugs is that they can also appear when something happens to your dependencies or something changes in your dependencies. Maybe another coworker is changing those dependencies, the behavior of those dependencies in your program, or maybe you have an API call and that API call is returning data to you in a different format than what you're expecting. And so if that API changes or some coworker has changed some of the dependencies in your program for a certain feature, then that's when the regression bug will show up. Okay, the second common bug that I've encountered a lot is the edge case bug or the corner case bug. And this kind of bug is a bug where you have a algorithm and then you've implemented this algorithm and it can handle all the general cases, but it doesn't handle certain specific cases. And the reason why it's called edge case or corner case is I believe it's because when you have an array and then your program is able to do the algorithm with the array in the normal and the general part of the array, but it starts to mess up when it reaches the edges of the array, like in the beginning or at the end of the array. And so when it reaches those edges of the array, then the program messes up. And so those are called edge cases. And then the corner case would be like if maybe your array is 2-dimensional, the error only happens in the corner of those arrays. So if you have a 2-dimensional array, it only happens when the algorithm is processing data in these 4 corners of the array. And so those are more rare than the edge cases, but then the edge cases are more rare than the cases that are in the middle of the array. The edge case or corner case bug may not involve arrays at all, but the idea here is that there's a case in your program that is not handled correctly, and this case is a rare case. Usually when I've encountered this bug in my programs, it's because I didn't fully test my program or my feature or my algorithm through all the different cases that I could think of. Maybe I was just doing the general cases and then I saw that it worked, and then I didn't see why it wouldn't work for other cases. Or maybe there are some other cases that I didn't expect. For example, like I would make a feature and then I'll give it to my supervisor, and then they would test my code, and then they would try these different combinations, different cases to try to break my program, my code. Another instance where I would encounter this bug is when I would integrate my code with someone else's code. And usually this happens when I'm not expecting their code to interact with my code in a certain way. Maybe they're giving me data in a different format, or they're giving me the wrong byte or the wrong information when I query something from them. And so that's when I would run into cases that I didn't expect. All right, the third and last bug that I'm going to talk about for this video is the implementation bug. And this implementation bug is a bug that happens when I'm implementing a new feature in our program. And say there's a design, or say I've made a design for some feature that I'm supposed to implement, and then I start coding it, and then in my mind, my logic is correct, but then when I actually test it out, it doesn't work. Two things that could be happening in the implementation bug. The first one is I could be misunderstanding the problem, and so the solution that I come up with is not really addressing that problem. So that's the first one. The second one is maybe I have a good design, good solution for the problem. Maybe I understand the problem correctly, but then when it comes to actually translating my idea into code, there's something I overlooked. Like there's a step that I missed, or there's some numbers that I didn't factor in correctly when I translated it into code, so my implementation of the design is wrong. All right, now let's talk about some strategies on how to fix these bugs. So let's start with the easiest one, in my opinion, the regression bug. That's the one that I think is the easiest one because it's worked before, so we can make it work again. And usually when I've encountered this bug, usually I go back to the last version where this bug was known to be working, and then I can compare it with the current version and then do a diff between that code that was where it was working and the code that it is currently. And then I know that the problem was caused by one of these different one of the code changes. The code differences are what's causing the problem. And so I can just narrow down which code change caused the bug to happen. And this is when Git really shows itself to be useful, because Git allows you to manage different versions of your code. And so a lot of times in my company, my supervisor would come and tell me that a bug happened, like a regression bug, and he would tell me that something that used to work is no longer working. And then I would just go through the versions and say, okay, which commit was the one where this code was last working, and then I would just do a diff between that commit and the current commit. And if you don't know what commits are, or you don't know what Git is, you can watch my other videos about Git. And this is why Git is really useful for developers, because regression bugs are really common, and Git is really useful for helping solve those regression bugs. All right, so now the edge case, corner case bug and the implementation bug. What are some strategies on how to fix those bugs? So first thing you can do is just look at your code again and see if you're missing something. Try to go through the logic, go step by step. And usually if you take a step back from your program and then maybe you take a walk, then you come back to your program and then look at it again. Having fresh eyes to look at it, that might be enough to be able to uncover something you did wrong in your implementation. Another thing you can do is you can try to make sure that you can reproduce that problem with consistency. If you have a bug in your program and you're running into edge cases and corner cases, but you can't really time when it happens, it's kind of random when that bug shows up, then it's going to be hard to debug. But if you can manipulate your test in such a way that those cases show up every single time you run the program, then you have a lot of chances to figure out what's going on wrong. And then that's when you can employ some debugging techniques like using breakpoints or using a log message to uncover what is going on wrong when those cases happen. Our last helpful tip before we go to the example is you can use process of elimination to try to narrow down and isolate what could be causing the problem in your code. And so say you have a bunch of different functions in your program, and then you can do some tests to see which function is the one that could be causing the problem. So you can narrow it down. Is it this function or is it this function? And then you can use log messages or you can use breakpoints and then try to see if the first function is giving you, if it's returning you what you expect, or a method, and you're making sure that it returns what you expect. If that one is returning what you expect, then you can use process of elimination and say, okay, that part of the code is fine. And then you can move on to another section of your code and see if there's something there that could be messing up. All right, now let's go through an example of how to debug. So say we have this code here. It's a really simple code, and then we're going to implement a feature, and then the feature is going to have a bug, and we're going to try to debug that implementation. So we have this code here, and it just has an array here, numbers, and then we're just printing all the elements inside this array. So let's run this code and see what happens. Okay, there you go, 1, 2, 3, 4, 5. So it's just printing the elements in the array. And say my supervisor asked me to write a function that will just do this part for me, that will print the array. And then so I'm going to create a function, and it's going to have some bugs in it, and then we're going to debug those bugs. Okay, so here I created a function called print array, and then I just feed the array into the print array, and then I have the array here, and then I use this for loop to print the array. So let's run this and see what happens. Okay, so we see here it prints 1, 2, 3, but it doesn't print the 1, 2, 3, 4, 5. And so what's going on here? And actually you can look at this warning here. This warning already gives you some idea of what's going on. And it says here size of R, which is this guy here, will return the size of the pointer, not the array itself. So we can call this an implementation bug because there's some details that are overlooked, and this has never worked before. So we've never had this print array working before. So this is an implementation bug, and there's an overlooked detail where we do size of R, but this actually doesn't give us the size of this array. So this warning here is really helpful at giving us more information about how functions work, and when you pass an array into the function, it actually doesn't give you the information about the size. And so what we need to do is we need to create a new variable here that will give us the size, and so we should calculate the size outside of the array. So we should move this calculation and put it here. Okay, so now we're calculating the size outside because we know that this has worked before, right? We know that we had this line before. So thankfully I have a Git repo that has my original code. So I can look at my original code and I know that this has worked before, this size calculation, and I know size was calculated correctly here when I had it before. And so I know this should work again when I implement this function. All right, so I brought that line back in here, and then we're gonna pass the size to the print array. And then the print array is going to take that size, and then let's see if this works now. Okay, so now the output looks a lot better. We don't have this warning anymore, and now it's printing 1, 2, 3, 4, 5, but it's printing an extra element here, this one here. And so something's still wrong with the print array function. So something we can do is we can add some log messages here. So we can do something that I would be interested in is if we could print the I here before we print the value inside that array. So if we can add some log message here. So let's run this, and we should see I should only go up to, if you look at this numbers array, it should only go to 0, 1, 2, 3, 4. Okay, so this makes more sense. I is 0, and then the element or the value of that element in the array is 1. 1 corresponds to 2, and then 4 is 5. So that's all correct. But then for some reason, I is 5 is going to be 1. And so here we can already see this is an extra output that we don't expect from this for loop here. Another log message we could do is we could just print the size to make sure the size is what we expect. So let's run this. Okay, so we get the size of the array is 5. Let's check that. Is it actually 5? Yes, it is correct that it is actually 5. So here we can use process of elimination. So we know that the size that was given to print array is actually correct. So there's nothing wrong with this line here. So this line is good. If you have enough intuition and you know that the for loop is going one extra time, then you should know that the problem is happening with this line right here. And so you can actually see it's I less than equal to size. If you look at our original code here, when we had the for loop, it was just I less than size. And so here we can use our regression bug technique where we saw that it worked before. And so we can look at how did it work before. So you come back to your code and then you say, okay, when it was working, it was I less size. And so we remove the equal sign there. Then let's run it again. And then you say, okay, there you go. So now the numbers 5 is not showing up. And then we can remove this end of line character. We can remove our log messages here, comment them out. And then there you go. So now we're actually printing the array correctly. Now, I wanted to show you another way that you can debug your code using a debugger. So in order to use the debugger in your VS Code, you just have to install this extension Code Runner. And then go here. I already have it installed, but this is the extension you want. And then we can put a breakpoint here. And then let's remove this here. Then we go to debug. Okay, so now we're at the beginning of main, and then we're just gonna step through. And then here you can see size here is correct. So size is 5. So this is when a debugger is really useful. You can see the values right away. Okay, here we have the size of the array is 5, and so that's from this print statement here. Okay, there's the first one, and then you can actually check the value of I. So this is the first iteration when I is equal to 0, and then it went through. Okay, so now we have printed all the elements of the array, so it should stop here. It should exit the for loop now, and then we see here I is equal to 4, and then size is equal to 5. Okay, so we saw the I increment, I is equal to 5, and then we're seeing that it's going back into the for loop. And so this is where the issue is happening. And that's because I is equal to 5 at this point and size is 5. So we know that because of this condition here, because I is equal to size, it went into the for loop an extra time. So if we remove the equals part, like we saw in our GitHub code with our original code, then I equals 5, this case wouldn't be going through because I is 5, 5 is not less than 5, which is what size is, and then it would exit the for loop. So now we know for sure, based on how the debugger is going, we know for sure that if we remove that equals, then we wouldn't go into this for loop that last time. So let's rerun this program and make sure that when I is equal to 5, it just skips over this for loop. So now we're at the top of this for loop, and I should turn into 5, and then we should jump down to 9. We shouldn't go into the for loop again, because when I increments from this instruction here, it's going to be 5, and it's no longer going to match this condition. This condition statement is going to be false, so it's not going to go into the for loop again. It should jump over here. And there you go. And then we exit the program. So it's going to return 0. And this is the expected output. So now if we remove this part here, we remove this part here, remove this end of line character that I added, then we run the code, and there you go. So now we're printing the array the way that we expect. All right, so there you go. Now you can debug your code like a pro. I talked about 3 categories of bugs that I've found over the years, 3 common categories. The first one is the regression bug, where it's a bug where your code used to work, or a feature used to work, but now it's no longer working. So that's easy to fix. You can just look at your git commit history, and then you can see when it was working before and compare your current code with that version. And then the second bug I talked about is the edge case corner case bug, which is a bug that shows up when your code has a case that you haven't handled yet. So all you need to do is handle that case. And then the last bug I talked about is the implementation bug, where in theory your code should work, and you've never had this work before, but you just have to keep thinking about your code. Think about maybe there's some details that you overlooked. Maybe you implemented your code incorrectly, so maybe you just need to relook at your code to figure out what's going on. Or you can use those two methods that I just showed you on how to debug your code. You can use some printf statements or some log messages to get the values of your variables as you're going through your program. Or you can use the debugger and step through your code line by line and make sure that all the variables are what you expect, and make sure that your code is running through the lines of code as you expect. And so that's how you can debug your code. If you want another detailed debug breakdown video, I have this other video about how to address this common scanf mistake. So this is the code from one of my students, and so in this video I show you how to fix it and how to use some debugging techniques to fix that code. Like I mentioned earlier, I have a free workshop for you, my Capstone project workshop, and in that workshop I go over 3 secrets to coding your own Capstone project in just 3 months. So if you want to become more proficient at creating your own projects, you want to move on from these tutorials and create your own projects, then be sure to check the link in the description and watch my coding workshop today. Alright, that's it for this week's video. I hope it really helped you out and helped ease some tension or ease some stress that you are encountering as you're debugging your code. And if it did help you out, please like, share, and subscribe to the channel. And if you have any other questions or comments, or if you have any other techniques on how to debug code, please let me know in the comment section. I'm really curious to hear your methods for debugging code. If you have any other questions, let me know in the comment section and I'll be sure to answer you there. And I'll see you in the next one. Peace.